just going to go through multiplying fractions. Technically, the next thing in the modules is dividing fractions, but as Mr. Chen and I were talking about it, like it doesn't really make sense to divide fractions if they don't know how to multiply fractions, because you'll learn dividing is actually just multiplying fractions. So we're going to do this one today to make sure you guys have the background skills in order to do what we're going to be doing once we get back in the modules. So this is why we need you to have two colors. So we're going to go through some models on these first, so that you guys can see the visualization of why the math works the way it does. Okay? So once we're done, we're only going to do one model for each type of the fractions that we're going to be doing today, just to give you that idea. And then after that, once you've got the concept, we're just going to do the math. So we're going to kind of do a little bit of both today. Our first one, we're going to start off with, again, marking our text, as we always should do. So Ms. Martin baked brownies for Thanksgiving parties. The guests were so stuffed they barely ate any of the pan brownies. She had 2/3 of a pan left. Mr. Martin found the brownies after dinner and loves brownies, so he ate 5/6 of the brownies that were left. What part of the whole pan of brownies did Mr. Martin eat? So to do this, we've got to break our model up into two pieces, because two things have happened in here, right? So first off, we had 2/3 of the pan left. So let's go ahead and break our pan into thirds, like this. Then we're going to color in 2 of the thirds. So this is where your first color comes in. Okay? Now, I know it's going to go a little faster with me on the board, so I'm actually going to pause for the recording's sake while you guys are doing yours. Okay, on the next part, now that we've got those colored in, so we have to now take care of the 5/6 of the brownies that were left. So we're going to go the other way to look at the way this one goes. So to do 5/6, I would actually just start in the middle to do your first one, and then you're cutting each of the other ones into thirds. That'll make it a little bit easier for your lines to be a little bit closer to what they should be. So that is now, we've cut this down to 6. So now we're going to color in 5 of these. So this is where your second color comes in. Take your second color, and just go ahead and start at the left, and we're going to color 5 of the 6 going across.
Okay, so now we have shaded in 5 of each of our rows of 6. Does everybody see that?
Yeah.
So we're going to look at the color that has 2 colors overlapping, which made green. Each of these pieces is how big?
1/18.
It is 1/18. So in each piece, I'm going to write that because it'll be easier for you to see. So if we put all of these together, how many pieces of brownie did Mr. Martin eat?
10/18.
He ate 10/18
Of the whole pan.
of the whole pan. Yes?
That simplifies.
Can I simplify this?
Yes.
By doing what?
By 2.
I can divide by 2, and I get 5/9. Are there any questions about how I did that or how I got the answer? Yes?
Why is there a 1/19?
It's not supposed to be a 19th. The board only works when it wants to work. There we go. Thank you. Is that better? Are there any other questions? All right, so if we look at just the problem to work out a multiplying fractions problem.
Okay, so when you look at the double shaded, how many oh, you already did all that part, sorry. So what do we notice? What are we actually doing? If we look at 5/6 of 2/3, we write that mathematically, 5/6 times 2/3. So what's 5 times, and what's 5 times 2? 10. What is 6 times 3? 18. Does that look familiar?
Yep.
That's what we just did, right?
Mm-hmm.
So we can look at this and say, well, first let's simplify that. So I can divide those by 2 to get me the 5/9. So how did we get there? What did we do? When multiplying fractions, our first step is we multiply top times top. That seems to be a dead spot in our board at this point. So top times top. Then bottom times bottom. And what do we always do on fractions?
Simplify.
Good. At least you guys can say it, even though there's still too many of you not doing it on your quizzes. But yes, we always simplify, right? So multiplying fractions is actually the easiest operation you can do with fractions, guys. You don't have to worry, like when we're adding or subtracting, you got to have a common denominator. When we're dividing, we're about to get to that. But there's a trick you got to do on dividing. Multiplying, it's bam, it's just multiply top, top, bottom, bottom, you're done.
Yes.
Well, then simplify.
Are we going to learn to define?
That's our next one.
That's our next lesson.
Oh.
Okay? Any questions? Everybody got that down? Okay, go ahead and turn the page. Okay, next one's going to be a little different. Mr. Johnson owns 4 acres of land that he uses to farm for vegetables. 3/5 of his land is pumpkins. What part of Mr. Johnson's land is pumpkins? So here's what makes this one a little unique. How do we start? We have 4 whole acres. So our first color is actually just going to be all 4 of these. So you can color in all 4 boxes. Okay, now we have that one done. We need to look at the other thing that is happening in our scenario here. That other thing that's happening is he's now dividing each of these acres into fifths. Okay, so we now divide these into fifths. We're going to do that for all 4 of the acres. That is actually a really key concept, that he's taking these wholes and he's dividing them into fifths. So basically, each one of these lines is 1/5 of each acre. Okay? So now, how many of those fifths did he actually use?
3.
3. So our next color going across, we're going to color 3 of each of these fifths now. Now we need to analyze our picture so we can figure out exactly what's happening. So he started with 4 whole pieces, right? But now that we have our double colors, how many are double shaded? 12. So we have 12 that are double shaded, don't we? Here's where this one gets a little confusing. Because he was dealing with whole pieces, what did he cut those whole pieces into? Fifths. So I have 12 after I cut my holes into fifths, right? So, how many times does 5 go into 12? 2, with what left over? 2 fifths. And if you count, it actually makes sense. Because basically, for every 10, I have a whole one, right? Because a whole one is 5. So if I did 12, and I did it by the way we've done it, that would be 5 here, 5 here, and then 2 more there. It would be 12 of the whole set. Does that make sense? So what we really did mathematically is we look at this. The 3/5 of 4 I now write as a multiplication problem, 3/5 times 4, but I can't really multiply by a whole number, can I? So instead, I turn it into an improper fraction by putting it over 1. And now we follow that same rule we did in the first one, which was 3 times 4 is 12. 5 times 1 is 5, which then simplifies. 5 goes into 12 2 times with 2 left over. So that's my new numerator. 2 and 2 fifths. Just like we saw from our picture. So to multiply fractions and whole numbers, first thing we need to do is put a 1 under the whole number. I need to bring this down. It's supposed to say under. Under the whole number. Then multiply top times top, bottom times bottom, and simplify. Okay? So basically what we're doing is making that whole number an improper fraction by placing it over 1. That now allows us to do the rest of that math, which is just top times top, bottom times bottom. Questions on how we do it with whole numbers? And this one we'll actually be seeing as we continue on our work today. So our last one is where we're going to get a little even more complex. So Miss Smith has 3 3/4 bags of chips left in the pantry. Her dog found them and ate half of the chips. What fraction of all the chips did her dog eat? There's our question. So in order to do this, we're going to start by dividing them and going across. We're going to divide them into fourths because she had 3 3/4 bags. So we're going to divide these into fourths. So to get 3 3/4 of the bags, we're going to completely color in the first 3, but then we're only going to go 3 of the last 4. Okay? So that's our first color piece on this one. Now that we have that first part colored in, our second part of the situation says the dog ate half of them. So we're just going to cut straight through and divide each of these in half. Okay? Now, we're going to color in half. So it really doesn't matter if you do top or bottom. I'm going to do top. If you do bottom, it's not wrong. It just won't be as good as mine. Okay, so now let's do our count again. So our first one is our double shaded. How many double shaded sections do we have? There's 4, 8, 12, and then 3 here, so that's a total of 15. Here's our key question, though. How did we split this up? How did we divide it? We divided it into how many sections? 8. So I have 15 out of the 8 sections. So the same thing we did before, we now need to simplify. How many times will 8 go into 15? 1 with how many left over? 1 with 7/8 left over. Does everybody see that? So mathematically, what did we just do? Mathematically, we took our half and we multiplied it by 3 3/4 times. So the next one, I'm going to teach you guys a little trick here. Hopefully you guys have done this before on turning mixed numbers into improper fractions. But here's one that might help some of you that struggle on this, help you remember how to do it a little bit. I don't know how many basketball fans we have in here, but one thing I've always enjoyed in basketball is the slam dunks, because they look pretty cool, and it's something I will never be able to do. Maybe if I go off a trampoline. But when the basketball player comes towards the basket, he takes the ball in his hand, and he goes really fast on the bottom, right? He's got to get it up in the dunking position. What math operation do we do that goes really fast? Multiplying, right? Makes sense? So he goes really fast, and he gets to the top, and he waits till he gets to the basket, and he just bangs it in. So what's that slow part? What's our math sloping? Adding. Our slow operation is adding. So that's what we're doing when we're turning a mixed number into an improper fraction, is what we call slam dunk. We go really fast, I'm going to multiply the 4 times the 3, but then at the end I go slow, so I'm going to add that last 3 in. So I can rewrite this 1/2 times, what's 4 times 3?
12.
12 plus 3,
12.
15. But just like always, we don't change our denominator. It's just 4. Okay? And now, just like we've been doing, I multiply. What's 1 times 15?
15.
What's 2 times 4?
8.
Which simplifies to
1.
So you see mathematically exactly what we did in our model. You guys starting to see where these are coming from now? Make sense? Good. So when I have mixed numbers, the first thing I've got to do is slam dunk. Or, I'll go ahead and put it in here, improper fraction. Once I've done that, then I multiply top times top, bottom times bottom. What do we always do? Simplify. And we're seeing why we're doing what we're doing mathematically. Those models kind of help you visualize what's going on. So that's kind of the whole purpose of those models, is so you can kind of visually understand why the math makes sense. So you can see that mathematically, if we just follow these rules that we just developed, you'll be able to get the answer that the models would show. So if the models help you, feel free to use them. Quite frankly, I'm not a huge fan of models. I don't think Mr. Shan is either. Oh, I forgot to share our story.
That was not going to remind me.
I gotta share this. She gave me permission, so I've got to share this. Mr. Shan and I actually do prepare these lessons, guys. We go over this stuff ahead of time so that we can make sure we're on the same page on how we're addressing everything. And when I was going through this model right here on the whole numbers and the fractions, Miss McShannon was looking at this and she's like, Mr. Moore, I just don't get this. She's like, I used to teach this with illustrative mathematics, and they taught this totally differently. So she actually went to a computer and she wrote it all out on a piece of paper, and she brought me the paper, and I looked at it and I said, Miss McShannon, that's what I just drew. It was exactly this exact same thing, except she drew her lines up and down instead of to the side. And in her defense, she had put the 1/5 on there. In my initial model, I didn't like that those were each 1/5, but she brought me the exact same model that I had just shown her as how to do this. So we were actually on the same page. We just didn't realize it until she showed me the model. And she still denies that we're on the same page. She still thinks her way is different. But I'm like, we even had Miss Tarbox come in, for those of you that know her. And I'm like, Miss Tarbox, look at the board, look at this picture. Do you see a difference? And she's like, no, it's the same. Because I did turn it on its side. But it was the exact same picture. So anyway, just a little anecdotal side note for you guys. We do work on this. We do actually go through this to make sure. And that's what our Tuesdays are for, is not actually just us sitting around like having fun when we're going through the lessons.
Oh, it's so fun.
It is fun. We were both laughing so hard on that one. Anyway, now that we've got that concept down, let's actually just do some practice, okay? So our first one, really simple. 1/2 times 1/2. So what am I going to do if I have two fractions? Top times top, bottom times bottom. So we just go 1 times 1 is, 2 times 2 is, bam, I'm done. Did you, Porter?
Yeah.
Way to be honest, man. Okay, our next one. Miss McShannon doesn't like this, but I'm going to show you a little tip because I like to make life easy on myself. Remember our 4 key numbers? 2, 3, 5, and 7? What if I am multiplying fractions and I have that same key number on top and bottom? I can actually get rid of that number before I multiply. It's called reducing. Kind of what I showed you when we were cross multiplying, but it also affects here. Speaking of which, let me make sure I make this clear to you guys. When I have two fractions, bless you. Wow, Andrew. When I have two fractions with a times sign, that's top times top, bottom times bottom. When I have two fractions with an equal sign, that's where you cross multiply. Okay, so please don't mess that up. But here, I've got a 5 on top and a 5 on bottom, right? So I can divide both those by 5. 5 divided by 5 is 1, 5 divided by 5 is 1, and I can get rid of those. Now I just have 1 times 3 is 3, 7 times 1 is 7. And my answer comes out in simplest form. Now you don't have to do that. I can still do the math. I can do 5 times 3 is 15. 7 times 5 is 35, but now guess what I need to do? Simplify. What can I divide 15 and 35 by? 5. And what do I get? Same number. So why don't I like doing this? You're going to see this as we get down to these other numbers. But this now gives me 2 additional chances to make a math error. I can make a math error as I'm multiplying to bigger numbers, but more importantly, I can also make a math error as I'm simplifying once again. Okay? So by reducing, I now take away 2 extra chances at a math error, and I make the math easier for myself from the very beginning.
Why even do it that way? Yeah, why even teach yourself?
Some people like to do hard things. Okay, our next one, we now have a mixed number and a fraction. So we have to do our slam dunk. We've got to turn the mixed number into improper fraction. So 3 times 2 is 6, plus 2 is 8. Remember, I don't change my denominator. Times 1/2. I have a reduction I can do, the 2 and the 4. So that makes that a 2 and a 2 and an 8, sorry. I can divide them both by 2. 4 times 1 is 4, 3 times 1 is 3. Who knows how to go from an improper fraction back to a mixed number? Yeah, what do I do?
Take how many number from the denominator can go into the numerator.
Good, so how many times will 3 go into 4? 1. So what's left over? That becomes my new numerator. 1 1/3. So for those of you who don't like to reduce, let's look at it. I would have done 8 times 1 is 8. 3 times 2 is 6. Which I can now simplify. Divide those by 2 gets me 4/3, which I now turn into an improper mixed number, 1 and 1/3. So either way will get you the answer. Okay? Our next one, we now have 2 mixed numbers. Gives us 2 chances to slam dunk. So we'll slam dunk here and here. 5 times 5 is 25, plus 4 is 29, over 5. 3 times 3 is 9, plus 1 is 10. Any reductions I can do here? Devin?
There's an easier way to do that one. You can just multiply the fractions and then the whole number.
You cannot.
What?
No. That works with adding or subtracting, does not work with multiplying.
So you can't just multiply 5 by 3 and 4/5 by 1/3?
Nope.
Does not work.
Doesn't work.
You have to make it an improper fraction.
You gotta make it an improper fraction first. Okay? So let's do a reduction. I've got a 5 here I can get rid of. Give me 1 and a 2. 29, unfortunately, nothing else I can do with that. So now I just have to do that math. 29 times 2 is 58. 1 times 3 is 3. 3 goes into 5 once. With 2 left over, it goes into 28. 9 times. With 1 left over. 1/3. 19 and 1/3. Now, for those of you that don't like reductions, this is where I get to start having fun with you. 29 times 10 is 290. 5 times 3 is 15. Can I reduce that?
Yes, by a lot.
By what?
5.
By 5. So I can simplify that by 5. Now, I already have the answer there to make it easy for you, but if I didn't have the answer, you'd have to go 5 into 29 goes 5 times with 4 left over. 5 into 40 goes 8 times. 15 divided by 5 gets me 3.
Do you know how purpose again? 4 change color?
No,
Are you serious?
I'm serious. The smart board literally hates this long way to do this. This happened to us last class. I was like showing how great the reductions were, and then the smart board literally just changed the marker as I was writing. It just did it again. That's how much the smart board even hates this long way to do this. So I now do this. I'm going to that, so it goes 19 and 1/3. No, I didn't touch anything. You can even watch the video just to prove it. Okay, our next one, we have 1 mixed number, 1 fraction. So we have 1 slam dunk. 2 times 10 plus 1 gives us 21. 3/4 straight up. Any reductions I can do? Go ahead. What?
Never mind.
You don't see the reduction?
I was trying to tell you about something else that
What?
So wouldn't you just multiply both top 5 times 4 and then 5 times 5?
No, 5 times 5 and then add the 4. That's the whole slam dunk piece.
Hi, this is how much your boom mic.
Oh, we're using it literally.
Oh, okay.
Bye. Okay, there actually aren't any reductions. I was glad to see no one raise their hand. Remember, it has to be a top and a bottom. I can't do 2 tops, I can't do 2 bottoms. So that is one other caveat on the reductions. Make sure it's a top and a bottom. So without any reductions, now I just have to do the math. 21 times 3 gives me 63. 2 times 4 is 8. 8's going to go into 63 7 times with 7 left over. Do what?
Is that an 8?
Yeah, it's an 8. Okay, last one. We have a double slam dunk. Okay, so we'll do our first one. 6 times 1 is 6, plus 5 is 11. And the second one, 8 times 4 is 32, plus 3 is 35. Are there any reductions we can do on this one?
No.
No, unfortunately there's not. So this means we're just going to have to do the big math. So 34 times 11, 350, 385. Yeah, 35 times 11. So those who don't see that, all I did is I did 35 times 10 and then added 35 to it. So that's 35. 35 times 10 is 350. Add them all together, 385. And then 6 times 8 is 48. So we're going to have to do the long math on that. 385 divided by 48. So using a rounding estimation, that's almost 50, right? So 50 and 385 is almost 400. So almost 50 and almost 400 is going to go about 8 times. So that's going to be my first check. It should be close. We'll see how close we get. So 8 times 8 is 64 with 6. 8 times 4 is 32 and 6 is 38. Yeah, that was good. So that's just one left over. So 8 and 1 out of 48. So there's our answer. 8 and 1/48. Questions on any of these? No questions? Okay, we'll give you guys a chance to practice to prove that you actually get it. So we'll do the next 3 on your own. Miss McShannon and I will be coming around to help you if you need some help. But we'll go over these, we'll work on these right up till the lunch bell. So we'll cover them when we get back. Do this. Okay, so you guys should have finished up all 3 of these. Our first one, pretty straight up. I have one reduction I can do. I got the 2 and the 4, it gives me a 1 and a 2. 1 times 3 is 3. 5 times 2 is 10. Those of you who did not reduce, 2 times 3 gave you 6. 5 times 4 was 20. Then I can divide by 2, gives me 3/10. So it works either way. Uh-oh. There we go. Our next one, don't forget our slam dunk first. So 2/3 times 2 times 5 is 10, plus 1 is 11. Again, we have one reduction on the 2's, gives us 11/3. So that's going to go 3 times with 2 left over. Without the reductions, we had 22 over 6, which I can divide by 2 to give me the 11/3, and then get to 3 2/3. Our last one is probably the best one for our reductions. So we have a double slam dunk on this one. Gives us 10 plus 2 is 12. over 5 times 3 times 2 is 6 plus 1 is 7 over 3. Reduction, I've got that 3, so I go 3 divided by 3 is 1, 12 divided by 3 is 4. 4 times 7 gave me 28. 5 times 1 gave me 5. 5 is going to go in 5 times with 3 left over. Those of you who don't like the reductions, we did 12 times 7 was 84. 5 times 3 was 15. Which I can reduce both of those by 3, which is actually a problem in and of itself, recognizing that I can divide 84 by 3. Make sure you understood that. Gave us our 28 and our 5. So we saw then that it was 5 3/5. You guys feel okay on those? Questions on any of those? Okay, go ahead and turn the page. Do the line up. Because you're going to need a ruler. If you do not have a ruler, we've got the box back there. You may borrow one of ours. What you're going to do, never mind, Mr. Chance, just going to hand them out. Okay, this one should be really simple, guys. On this side, all you need to do is the math. So I do 1 times 5 is 5. 3 times 6 is 18. Don't worry about reductions on this side. On this side over here is your answers. So now on this side, I found 5/18. On this side, I need to find 5/18. What I'm going to do is I'm going to use my ruler. I lay it down between this dot and this dot. And when I do that, I draw a straight line between them. And you're going to go through one letter and one number. That letter and number tells you where that letter goes. So in this case, it was 7 and T, so I go to the bottom. In number 7, I'm going to put the letter T. Okay? You're going to do that for every problem. Once you're done, you should come up with a nice little math joke at the end. But in addition, on this side, where you can, we want you to simplify. So 8 and 35, can I simplify that? Can I divide them both by 2? Can I divide 35 equally by 2? Can I do it both by 3?
No.
Both by 5?
No.
Both by 7?
No.
Then I'm simplifying. That's how easy this is, guys. You do that 2, 3, 5, 7, you're there. 21 and 10, my numerator's bigger, so I know I can simplify this. 10 goes into 21 how many times? 2 with 1 left over. Okay? So on your paper, this is what we want to see. Your line going through. On this side, your simplified form for all of the answers. And then on the bottom will be a math phrase. I'll give you a hint. It's not a dinosaur.
Yes, it is.
It is not, Miss McFinish. Okay, so on the side, remember that you are required to simplify where possible. So we're going to do 5/18. Anything on that? No. What about the 35/18? Yeah, that one went 1 with 17 left over. So 1 and 17/18. 15/4. 3 and 3/4. 15/8. 1 and 7/8. 18/11. 1 and 7/11. 28/45. No. 11/60. No. 12/35. No. 99/100. 2/45. 19/36. 49/8. It goes 6 with 5 left over. Yeah, 1 left over. What am I thinking? I was thinking about moving that bar. And 48/7. That's going to go 6 and 7/8. And what was our message? Numerators are tops. The middle down with denominators. So numerators on top, denominators down below. Or the way I like to say it, numerator ceratops. The good old math dinosaur. And then on the last page, I don't have up here.
That was homework.
Guys, turn your the homework page real quick, please. Yeah, that's what we did last year. We changed it up. We decided to do this in class, and then we're doing the homework different. Everybody, turn to your last page, please. So, last page. Couple key facts on this. Number one, you must simplify the problem, or you're not going to find the answer down below. So you do the math. So for number one, you do all the math. You're going to come to a simplified answer. You go down to below, you find that answer, you cross that box off. Okay? So basically the answers are telling you which boxes to cross off. Once you've done all the problems and crossed all of the boxes off, you're then just going to go from left to right and start filling in the blanks down at the bottom, and you'll get a sentence that talks about the oldest table. Any questions on your homework? Okay? I know there's question problems, but honestly they're relatively simple. I will tell you if you can do your reductions before you get to the final, in other words, look for common factors that you're multiplying, that'll actually make it go even faster for you. But none of the numbers are really all that bad, so you shouldn't actually be in too much trouble on that one. Are you ready to finish it?
I honestly thought the answer was going to be periodic table. Yeah, me too.
Don't give it away.
Yeah, don't give
Don't give it away. Okay, thanks guys. That's it.